Okay. The question says, one vertex of a rhombus is at the point 0, 4. One diagonal lies along the line 3y minus x equals 2. And two of the sides are parallel to the line y equals to x. Find the coordinate of the remaining three vertices. Find the area of that part of the rhombus which lies in the first quadrant. So we are going to draw diagram to illustrate the information given to us. We start. Yeah. We have point A, 0, 4. We have diagonal 3y minus x equals to 2. When x equals to 2 to 0, y equals to 2 over 3. When y equals to 0, x equals to minus 2. So we have it. That's the diagonal. 3y minus x equals 2. We also have another information. It says that two of the sides are parallel to the line y equals to x. So when y equals to x, the gradient will be equal. So we have this and we have another one. So the gradient of these lines, let's call it A, B, C, and D. Let's call it A, B, C, and D. This is the diagonal. And these are the sides parallel to line x, y equals to x. From this information, we can see that line side AB is parallel, side AD, is parallel to BC. And they are all parallel to the line y equals to x. Hence, the gradient is equal to 1. For all of them, their gradients are equal to 1. So, let's find the equation of the sides. For side AD, y minus 4 over x minus 0 is equal to 1. So, y minus x equals to 4. Let's call that equation 1. So, we also have this 3y minus x equals to 2. We have to solve this simultaneous equation to get these points. Let's subtract equation 1 from 2. We have 2y is equal to minus 2. Hence, y equals to minus 1. And when y equals to minus 1, let's substitute in equation 1. So minus 1 minus 4 is equal to x. So x equals to minus 5. So we have solved for D now. We have this one as minus 5 minus 1. Now to get point B, we have an equation already. 3y minus x equals 2. We know that the distance from A to D is the same thing as A to B because it's a rhombus. All the sides are equal. So let's find the distance. The distance will be square of the distance. We have it as 4d squared AD squared, is equal to AB squared. So we have it like this. 4 minus 1 plus 0 minus 5 all squared is equal to 50. The distance B, let's call this x, y for now. So x minus 0 plus y minus 4 squared will be equal to 50. So we have x squared plus y minus 4 squared is equal to 50. We also have that from this equation now, you can see that x is equal to 3y minus 2. Let us substitute this in this equation. Let me call this one equation 2 for now. So I have 3y minus 2 all squared plus y minus 4 all squared is equal to 50. Now to find coordinate of B, I expanded this and at the end of the day, I got y squared minus 2y minus 3 equals to 0. At the end, I had y equals to minus 1 when x equals to minus 5 it gave us this point back. Y equals to 3 and then x equals to 7. That is point B for us now. I believe it's clear. Now let's look for the other point, C. Now to find point C, equation BC. I got it because we have already realized that the gradient is 1. So y minus 3 over x minus 7 equals to 1. So equation BC is y minus x equals to minus 4. Now, gradient of AB is equal to gradient of CD. So equation for CD is, I got the gradient for AB, which is 3 minus 4 over 7 minus 0. That gives us minus 1 over 7. So for equation is y plus 1 over x plus 5 equals to minus 1 over 7. So I have 7y plus 7 equals to minus x minus 5. So the equation later became 7y plus x equals to minus 12. So this one now, I brought it here. So 8y equals to minus 16. So y equals to minus 2 for the point C. So from there I substituted this into this equation. I got x equals to 2. So we are able to find the other 3 vertices. Now to find the area of the parts which lies in the first quadrant, let's make it O, A, B, E. So I now project this to be F. So if I should find the area of this trapezium, I will now subtract the area of this triangle from it. The area of this trapezium will be of this quadrants, of this quadrilateral that lies in this quadrant will be trapezium, area of trapezium O, A, B, F minus area of triangle E, B, F. And how do I get that? It will be half into, this is 4 plus this is 3. What's the distance? 7 minus, what's this place? Okay. Now, the equation of this place now was given as y minus x equals 4. Now, we have this line to be y minus x equals to minus 4. When y equals to 0, that is here, x will be 4. So this place is 4, 0. So we can see the distance EF now. So our triangle will now be half height, that is 3, times 7 minus 4 times 3. So we have this to be equal to half 49 minus 9, which gives 20 units. I believe that's clear. The point A, 1 minus 2, B, 6, 10, C, 26, 25 are vertices of a parallelogram ABCD. 1. Find the coordinates of D. 2. The area of the figure. 3. The tangent of the angle between the diagonals AC and BD. Let's first of all draw a diagram to represent the parallelogram, approximate diagram. Now this is diagram. A, 1 minus 2, B, 6, 10, C, 26, 25, D. And this place is parallel to this place. This place will be parallel to this place. Now we are trying to find point D. Let's see. From here, BC is parallel to AD. That is, their gradient will be equal. And BC is parallel to AD, yes. AB is parallel to CD. Now, we can now solve it. Gradient of BC will be 25 minus 10 over 26 minus 6, which is 15 over 20. 3 over 4. So gradients, That's gradient of BC. Now gradient of AB. AB. That's 10 plus 2 over 6 minus 1. That is 12 over 5. So from this, we can get equation CD and AD. And the point of intersection gives us point D. Let's get equation CD. CD. That is y minus 25 over x minus 26 is equal to 12 over 5. Now to find point D. I've already gotten the gradients, so I got equation for CD and AD. So for CD, y minus 25 over x minus 26 equals to 12 over 5. So I got this. 5y minus 12x is equals to minus 1 is 7. For AD, since it is parallel to CB or BC, I have 4y plus 8 equals 3x minus 3. So at the end of the day, I got this equation, 4y minus 3x equals minus 11. Substituting simultaneously, I multiply this one by 3. I got by 4 rather. 4y minus 3x minus equals minus 11 by 4. So I got this. So at the end of the day, I was able to get x equals to 21, y equals to 13. So the area of the figure will now be simplified. I can do it by breaking it into various shapes. Or I can do it by saying, since I know the distance, I know the equation of this line, I can use the distance from here and then get it. The equation for AD is 4y minus 3x plus 11 equals 0. The perpendicular distance from B to AD, perpendicular distance from B to AD is given by 4 into 10 minus 3 into 6 plus 11 over square root of 4 squared plus 3 squared. And that will give me 40, 51 minus 18 all over 5. Now the distance is 33 over 5 units from B to this line, and the length of this line is distance AD, and that is 21 minus 1 plus 13 minus 2. That is 13 plus 2. So 21 minus 1 squared, and I was able to get this one as 25. So area of the parallelogram is vertical height times base, and that gives me 165 units squared. Now, the tangent of angle between the diagonals AC and BC. Gradient AC is 25 plus 2 over 26 minus 1. So that's 27 over 25. Gradient BD is 10 minus 13 over 6 minus 21. So we got down to be 1 over 5. Now, the angle between them, if AC is making angle alpha with the horizontal line, and BD is making angle beta with the horizontal line, the angle between them will be alpha minus beta degrees. So tan alpha minus beta will be equal to 27 over 25 minus 1 over 5 over 1 plus 27 over 25 times 1 over 5. Recall that we said tan alpha minus beta is equal to tan alpha minus tan beta over 1 plus tan alpha tan beta. We have treated this in our previous lecture. So the tangent of the angle between them will now be, because tan alpha is the gradient of AC. Tan beta is the gradient of BD. So we have 27 minus 5 over, and this one is 125 plus 27 125. So on I have 22 over 25 times 125 over 152. So the tangent of the angle between them is 55 over 76. The question reads, show that the equation x squared plus 4xy plus 4y squared equals 25 represents a pair of parallel straight lines and find their distances apart. So we have this equation x squared plus 4xy plus 4y squared equals 25. Then let's look at how we can factorize this. We have x squared plus 2xy plus 2xy plus 4y squared. So at the end of the day, we are going to have x into x plus 2y plus 2y into x plus 2y. So we are going to have x plus 2y, x plus 2y, 25. So we have x plus 2y squared minus 25 equals 0. Yeah, sorry. X plus 2y squared minus 25 equals 0. So we have x plus 2y minus 5. And you can see that this is difference of two squares. So we have x plus 2y plus 5 into x plus 2y minus 5. So these are the parallel lines, the equations of the parallel line. So one line will be x plus 2y plus 5 equals 0. The other will be x plus 2y minus 5 equals 0. These are the equations of the parallel lines. We are now asked to find the distances apart. There are two ways. You can look at their distance from the origin, or you can get a point on one of the lines and calculate the distance from the other line. This is what I mean. We have these lines. We can calculate the distance of this one from the origin, the distance of this one too from the origin, since they are parallel. At the end of the day, let's say this is the origin. At the end of the day, the difference in their distance from the origin will be their distance apart. Or we can find a point on this one and then find the distance from this line. Let's do this. Let me see. When x equals to 0 in this one, y will be equal to minus 5 over 2. So we have 0 minus 5 over 2 for equation for the first one. So the distance of this one from this line will be given as 0 minus 2, no, plus 2 into minus 5 over 2 minus 5 over 1 plus 2 squared. And that will give me minus 10 over root 5. That will be minus 10 over root 5. That will be minus 10. We are taking the negative of the roots because of this sign. So it will be minus 10 over minus root 5. So we are having 2 times 5 over root 5, which will be 2 root 5. Now let's look at the distance from origin for the two. The distance of this one from the origin will be, for line 1, distance from origin will be equal to 5 over square root of 1 plus 2 squared. This is 5 over root of 5. Please note, we are taking the positive square root here. For the second one, it's going to be minus 5 over root 5 for the line 2. So the difference in their distance will now be from the origin. Distance from origin will be equal to 5 over root 5 minus 5 over root 5, which will give me 10 over root 5. Why are we having this one? It means that they are on different sides of the origin. They are on different sides of the origin. That's what it shows. That's why one is positive and the other one is negative. So we have gotten the answers. Question says ABC is a triangle. A is the point 0, 3, and B is the point minus 5, minus 2. The other center of the triangle is the point minus 1, 1. Find the coordinates of C. That's the first question. 2. The area of the triangle. 3. The tangent of the angle ACB. We start by getting diagram to give us a view of what the triangle is going to be like. Let's start like this. We have 0, 3. That's A. B is minus 5, minus 2. Minus 5, minus 2. B is minus 5, minus 2. So we have something like this already. And we are also given that the other center is minus 1 and 1. So we have minus 1 and 1. Something like this area. So let's see. It's going to be like this. So C is going to be here. So, and we also know that the other center is the perpendicular from this point to the other line. So that's why it is called the orthocenter. Now, let's look for the area, the gradients of AB. We have gradients of AB as 3 minus 2 over 0 minus 5. So that is 5 over 5. That's the gradient of AB. So we can also see that, let's call this one D, E, F. The point of intersection of the orthocenter of the altitude from C to D to AB is D. The altitude touches AB at D, the altitude from C. So we can also know the equation of the line DC. So gradients of DC is equal to minus 1. We know why. They are perpendicular to each other. We also know that AE will also be perpendicular to BC. Therefore, the line from the orthocenter to D, we can find the equation of that line now. We can find the equation of that line. So we have y minus 1 over x plus 1 is equal to minus 1. And that gives us y minus 1 equals to minus x minus 1. So y plus x is equal to 0. Y plus x equals 0. That is line DC. Now, we have this one now. Let's look at BF. Line BF. That will be we know the gradients of line BF now. We have it as y plus 2 over y plus 5. Yeah, y plus 2 over x plus 5 is equal to minus 2 minus 1 over minus 5 plus 1. That gives me minus 3 over minus 4. So 4y plus 8 will be equal to 3x minus 15. So 4y minus 3x is equal to minus 23. So I have line from here. I have line DC. Okay. BF. Fine. Now, I can also find another line just to get point C. Now, for line BC, I know that AE will be perpendicular to BC. And the gradient of line AE will be the gradient of A to the orthocenter. So let's see. Line AE gradient will be equal to 3 minus 1 over 0 plus 1, which is 2. So which means that gradient of line BC is minus 1 over 2. Of line BC is equal to minus 1 over 2. Please note, this is the orthocenter. So this line is what extended down here. So this one, since it is perpendicular to this is the gradient of this line AO, and which extends to this one. This one is perpendicular to it. That's why I'm having minus half as the gradient of BE. Please note, very clear. Now let me find the equation for line BC. Line BC. The equation will be y plus 2 over x plus 5 is equal to minus half. So I have 2y plus 4 minus x minus 5. So 2y plus x is equal to minus 9. So I have equation for line BC and line DC. So the point of intersection of this one will be gotten through simultaneous equation. Therefore I have y plus x equals 0. 2y plus x equals minus 9. Subtracting equation 1 from 2. That will give me y equals minus 9. And if y equals to minus 9, x will be equal to 9. So I have 9 minus 9. That's the coordinate of C. Now, to find the area of the triangle, the line BC equation is 2y plus x equals to minus 9. And that is 2y plus x plus 9 equals to 0. I can find the length of the altitude from O to BC. And that will be gotten by substituting this here. So I have 2 into 3 plus 0 plus 9 over square root of 2 squared plus 1 squared. That is 15 over root 5. That is the height. The distance BC is equal to square root of 9 plus 5 squared plus minus 9 plus 2 squared. Because minus 9, minus 9 minus minus 2. 9 minus minus 5. So that gives me square root of 14 squared plus 7 squared. So I have 7 so 7 root 5. So the area will be equal to half base times height. So this one is 15 root 3. This one is 7 root 5. 15 over root 5, sorry. So area will now be equal to half times 7 root 5 times 15 over root 5. So this one cancels this. 7 times 15. That should give me 105 over 2. 52 and a half units squared. That's the answer for the area. Now to find the tangent of angle ACB. So the tangent of AC is 3 plus 9 over 0 minus 9. That's minus over 3. The tangent of BC is 9 minus 9 plus 2 over 9 plus 5. That is minus half. Now, the tangent of angle ACB is equal to tan alpha minus tan minus beta. That is the difference of the angles, tan of the difference of the angles. And that will be equal to tan alpha minus tan beta over 1 plus tan alpha tan beta. That will give me minus half minus 2 over 3 over 1 plus minus half times minus 4 over 3. And that gives minus 3 plus 8 over 6 over, let me call this 2. 3. So, is equal to 5 over 6 times 3 over 5. So tan ACB is equal to half. Now the question says, prove that the points minus 3, 4, 1 minus 4, 3, 7 are the vertices of right angle triangle, and find the equation of the line joining the midpoints of the hypotenuse to the opposite vertex and the circumradius. At the circumradius, we start by drawing diagram to show these points. Minus 3, 4. Minus 3, 4. Let's be here. That is A. 1 minus 4. 1 minus 4. That's B. And C is 3, 7. 3, 7. 3, 7. That is C. So you have something like this. Now we are asked to show that it's right angle triangle. There are two ways to show that. We can find the gradients of the sides and look at the relationship of the gradients. Or we find the length of the sides, and if they obey the Pythagoras theorem, it shows it's right angle triangle. Now, gradient AC, 7 minus 4 over 3 minus 3, that's 3 plus 3. I got 4, I got half. Gradient of AB is minus 4 over 1 minus 3. That is minus 8 over 4. That gives minus 2. The relationship between this one and this one shows that they are perpendicular to each other. So which is this angle here is right angle triangle. Another way is to show by the length of the sides. We find AC squared plus AB squared to be equal to BC squared. Let's show this. So we can see that AC squared is equal to 45. AB squared is equal to 80. BC squared equals to 125. So AC squared plus AB squared gives BC squared. That is, it proves the Pythagoras it obeys the Pythagoras theorem, showing that it's the right angle triangle. At the same time, from here we saw that gradient of AC is equal to minus 1 over gradient of AB. So it shows, this one also proves that it is right angle triangle. Right angle triangle. Now, the next question says find the equation joining the midpoints of the hypotenuse to the opposite vertex. This is the opposite vertex. This is the hypotenuse. Let's find the midpoint of the hypotenuse. let's call that m. It's going to be 3 plus 1 over 2. And then 7 minus 4 over 2. So that will be 2 and 3 over 2. So the gradient of the line joining this place to this place will be gradient will be 4 minus 3 over 2 over minus 3 minus 2. And I have that as 5 over 2 over minus 5. This should be 5 over 2 times 1. Which is 1 over minus 2. That's the gradient. Therefore, we have y minus 4 over x plus 3 will be equal to minus half. So 2y plus 8 equals to minus x minus 3. So 2y plus x equals minus 11. That's the equation of the line joining the midpoints of the hypotenuse to the opposite vertex. The circumradius will be half of this because the circumcenter will be on the hypotenuse of a right angle triangle. So that will be half of BC. Circumradius is equal to hypotenuse over 2. So what is the length of the hypotenuse? I calculated it the other time. It was 125 square. So hypotenuse square is equal to 125. So hypotenuse over 2, which equals to the circumradius, will be equal to square root of 125 over 2, which is 5 root 5 over 2. So that is the answer to that question. The question says a square ABC has opposite vertices A and C at 2 and minus 5 and minus 4, 3. Find the coordinates of B and D and the equation of the lines which contain the sides of the square. Let us represent it diagrammatically. Let's say we have points like this. It says 2 minus 5. We have 2 here and we have minus 5 here. So 2 minus 5. That is A. And C, it says minus 4 and 3. So we have A here. Minus 4 and 3. Okay. So this is C. So we have a diagonal like this. That's what we have. 2 minus 5 minus 4 and 3. So and it says it's a square. So with this, we know that all these angles are 90 degrees. And the sides are equal. You have seen that. The sides are equal. Okay. Let me see. Minus 4, 3. The sides are equal, and all the angles are the vertices are 90 degrees. One thing we also know is that the diagonal will bisect the angles. So when we know the angle this one makes, it means that the other sides are going to differ from the difference between the angle of the diagonal and the sides will be 45 degrees. So let's look at it. What will be the angle here? What is the tangent of CA? Tangent of CA we can see that it's going to be 3 minus 5 over minus 4 minus 2. 3 minus 5 over minus 4 minus 2. And that gives me 8 over minus 6, which is minus 4 over 3. I can see that this one is A, C. So let me make this one B and D. The line AB is parallel to CD, and the angle and the line CB is parallel to DA. The difference between the angle of AB and line CA is 45 degrees. So here will be 45 degrees, and here will be 45 degrees. So the gradient of this line will be tan. This one is alpha. Alpha minus 45. The gradient of this one will be tan alpha plus 45. So let me find the gradient of this one and the gradient of this one. Gradients AB and CD is going to be minus 4 over 3 minus 1, because tan 45 is equal to 1. So the difference, I am getting this, the tan alpha minus 4 over 1 plus minus 4 over 3 times 1. So this one gives me minus 7 over 3 over 1 plus, so it's 3 minus 4 over 3, which is minus 7 over minus 1 over 3, minus 7 over 3. So this one gives 7. So the gradient of AB and CD is 7. From our knowledge of perpendicular lines, we can also say that gradient of CB and DA is minus 1 over 7. Minus 1 over 7. From this, we can easily get the equation of the sides. The equation of side AB. I can get it by saying y plus 5 over x minus 2 is equal to 7. So I can say y plus 5 is equal to 7x minus 14. So y minus 7x is equal to minus 19. That is for AB. Now for CB, I can say y minus 3 over x plus 4 is equal to minus 1 over 7. Minus 1 over 7. So I can also say 7y minus 21 is equal to minus x minus 4. So 7y plus x will give me 17. So if I should solve this simultaneous equation, I am going to find point B. And let's do that. Y minus 7x equals minus 19. 7y plus x equals 17. Let's multiply this by 7. 7y minus 49x will be equal to 3, 6, minus 133. Minus 133. So, subtracting this one from this, I'm going to have 50x is equal to 150. X is equal to 3. If x equals 3, 7y is equal to 17 minus 3. Y will be equal to 2. So this point B is going to be 3, 2. B is going to be 3, 2. I can use any technique to get this place. Either by distance, I can equate the distance or anything. But let's follow the pattern we have started with. Now for equation CD, that is y minus 3 over x plus 4. So for equation CD, we are going to have y minus 3 equals to 7x plus 28. So y minus 7x equals 31. That's equation CD of line CD. Now for equation AD, we are going to have y plus 5 over x minus 2 is equal to minus 1 over 7. So this gives 7y plus 35 is equal to 2 minus x. So 7y plus x equals minus 33. That is for equation AD. So we now solve it simultaneously. Let's multiply this one by 7. We have 7y minus 49x is equal to 217. Therefore, subtracting, I have 50x is equal to minus 250. So x equals minus 5. For this point, x equals to minus 5. And let's solve for y. Here. So y minus 7 into minus 5 is equal to 31. So y plus 35 equals to 31. So y equals to minus 4. So this point is minus 5, minus 4. So our points now are C minus 4, 3, B 3, 2, A 2 minus 5, and D minus 5, minus 4. And the equation for CD is y minus 7x equals 31. Equation for AD is 7y plus x equals minus 33. So that is the solution to this question. Given that the centroid of a triangle is 2/3 of the distance from the top to the middle of the base, prove that the triangle with vertices x1, y1, x2, y2, and x3, y3 is 1/3 x1 plus x2 plus x3, and 1/3 y1 plus y2 plus y3. Find also the coordinates of the centroid of triangle with sides along the lines x plus y equals minus 1, x plus y minus y equals 0, x minus y minus y equals 0, x minus 3y plus 3 equals 0. Hence, show that the points P, 2.8 and 1.9 lies inside the triangle. Now let's start. Let's say you have a triangle. Let's say x1, y1, x2, y2, and x3, y3. Now, the midpoint of this one, from our knowledge, is x1 plus x2 over 2, and y1 plus y2 over 2. That's the midpoint. And we have also learned that the centroid will be dividing this line in the ratio 2 to, let's see, is 2. This one is 2 over 3 of this line. So it means it is dividing it in the ratio 2 to 1. That is, this one is 2/3 of this whole line. Then, let's call this place C, centroid. So XC, since it is divided in the ratio of 2 to 1, we multiply this one by 2 and add that 1 to it. So we have 2 into C, 2 into x1 plus x2 over 2, now plus x3. We now divide by 2 plus 1. Same thing goes to the y side. 2 into y1 plus y2 over 2 plus y3 over 2 plus 1. So that gives us, this one cancels this. We have x1 plus x2 plus x3 over 3. And we also have y1 plus y2 plus y3 over 3. So that one is proved already. The centroid is 1/3 of the sum of the vertices. Now we have to find the coordinates of this. So we have points x plus y equals to 1, x minus y equals to 1, x minus 3y equals to 3. So to find the 3 points of the triangle, we have to get these two equations to join them into 2 places. And this, as in, they have to be joining at the places where they join. Yes, those are the point of the intersection. So let's take this 1 and 2. So I have x plus y equals 1, x minus y equals 1. So on addition of this, I have 2x equals 2. So x equals 1. And then, if x equals to 1, y is equal to 0. So x, so one point is a, let's call a 1, 0. Let's take 1 and 3 now. X plus y equals to 1, x minus 3y equals to 3. Let's subtract this from the first one. That will give me 4y equals to 4. So y equals to 1. If y equals to 1, x equals 0. So another point is 0, 1. Let's now take the second one and the third one. That is x minus y, x minus 3y equals 3. Oh shit. So for this triangle, to find the vertices, I have to solve for x and y using pairs of this equation to find the 3 points, the 3 vertices. And I have x minus 3y equals minus 3. Now let's take equation 1 and 2 now. X plus y equals 1, x minus y equals 1. So on adding these two, I have 2x equals 2. So x equals 1. So y equals 0. So one of the points is 1, 0. Let's also look for another point using 1 and the first and the third equation. X minus 3y equals minus 3. So let us subtract the second equation from the first one. I have 4y equals 4. So y equals 1. If y equals to 1, x equals 0. So another point is 1, 0, 1. Let's now use the second equation and the third. So let's subtract the second equation from the first one. So I have 4y is equal to 2y is equal to 4. So y equals to 2. When y equals to 2, here x equals 3. So the third point is 3 and 2. So we have a triangle with vertices 1, 0, 0, 1, and 3, 2. 3, 2. C, A, B. So that is the triangle now. And we are now asked to find the centroid the centroid of this triangle. The centroid, I have 1 over 3 into 1 plus 0 plus 3. And 1 over 3 into 0 plus 1 plus 2. So this one is, the centroid is 4 over 3 and 1. So that's the centroid. So the centroid is 4 over 3 and 1. We are now asked to show that 2.8 and 1.9 lies inside the triangle. We have to find equation of the lines. We have the equation of the sides already. So we now check if the distance from the centroid and the distance from this point given, if they give us the same sign, it means they are on the same side of the line. Let's see. X plus y equals to minus 1. Yes, x plus y equals to 1. X minus y equals to 1. So let's see. The distance from here, x plus y minus 1 equals to 0. Let us substitute 4 over 3 there. Here, and 1. 4 over 3 plus 1 minus 1. So we have 4 over 3. That's positive. Let's check 2.8 now. 2.8 plus 1.9 minus 1. That's going to give me 3.7. That's positive. Now, let's look at the other equation. X minus y equals to 1. 4 over 3 minus 1. Okay. Minus 1. Let me make it like this. Equals 0. X 4 over 3 minus 1 minus 1. That is minus 2 over 3. But that is negative because the centroid is in the middle. It's in the center of the triangle. Let's now substitute 2.8 minus 1.9 minus 1. That gives me minus 0.1. Negative. Let's look at the third equation. X minus 3y plus 3. So if we put the centroid there, 4 over 3 minus 3 plus 3, that is positive. Now let's substitute 2.8 inside the equation. 2.8 minus 3 into 1.9 plus 3. That is going to give me 5.8 minus 5.7. So with this, we have been able to prove that 2.8 and 1.9 is inside the triangle. It's inside the triangle. The question reads, the coordinates of A, B, and C are 3, 1, 1, 5, and 4, 2, respectively. P is the midpoint of BC. Q lies on AC, and it's not that CQ to QA, that is the ratio, is equal to 3 to 1. R lies on AB, and that AR, the ratio AR to RB equals to 1 to 3. AR to RB equals to 1 to 3. Find the equation of the lines AP, BQ, and CR, and prove the lines are concurrent. Now, let's see. A is 3, 1. B is 1, 5. And C is 4, 2. Now, let's look for P. We are told that P is the midpoint of B and C. So, P, the coordinate of P is 1 plus 4 over 2. And 5 plus 2 over 2. That's for midpoints. So, the coordinate of P is 5 over 2 and 7 over 2. The coordinate of Q, we are told that Q lies on AC. AC. And the ratio of CQ to QA is 3 to 1. So we have to multiply 3 with the coordinates of A, sorry, and 1 with the coordinates of C. So 3 to 3 plus 1 into 4 over 3 plus 1, and 3 to 1 plus 1 into 2. 3 plus 1. So the coordinates of Q will be 13 over 4 and 5 over 4. Now, let's look for the coordinates of R. Coordinates of R. R is such a way that it is between A and B. 3, 1, B, 1, 5. So the ratio of AR to RB is 1 to 3. So this one we multiply the coordinates of B, and 3 we multiply the coordinates of A. So let's do that. 3 into 3 plus 1 into 1 over 3 plus 1. And then we have 3 into 1 plus 1 into 5. That is. So the coordinate of R now is 6 over 4, that's 3 over 2, and 8 over 4, that's 2. So our coordinates are this. We have gotten A, P, Q, 13 over 4, 5 over 4. R, 3 over 2, and 2. So we have gotten all these coordinates. Now, we are taught to find equations of some lines. So we are taught to find equation AP. Let's find equation of line AP. So for AP now, we have y minus 1 over x minus 3 is equal to 7 over 2 minus 1 over 5 over 2 minus 3. So this one gives 5 over 2, and this one gives minus half, minus 5. Therefore, y minus 1 is equal to 15 minus 5x. So y plus 5x is equal to 16. This is equation of line AP. Now let's look for the equation for the line BQ. BQ, I have y minus 5 over x minus 1 is equal to 5 over 4 minus 5 over 13 over 4 minus 1. So this is minus 15 over 4 over 9 over 4, which at the end of the day will be minus 5 over 3. So I have 3y minus 15 is equal to 5 minus 5x. So 3y plus 5x is equal to 20. Now, for equation, this is line BQ. For line CR, I have y minus 2 over x minus 4 will give me 2 minus 2 over 3 over 2 minus 4. And this is 0. So, which means that it's a straight line. Y equals to 0. Y equals to 2. So when y equals to 2, it means x can be anything. X is a straight line parallel to the x-axis. This is how it looks like. 2. So it goes straight. So it has all the values. Now, let us now look at what the value of x will be if y equals to 2 in equation in line AP and line BQ. When y equals to 2 in line AP, so I have 2 plus 5x equals to 16. So 5x equals to 14. X equals to 14 over 5. So, which means that it coincides at x equals to 4 over 5. 14 over 5, sorry. 14 over 5. Now let's put that 2 in equation in line BQ now. I have 3 into 2 plus 5x equals 20. This is line BQ. So which means that 5x equals to 14. X equals to 14 over 5. Which means that the point 14 over 5 and 2 is common to all. So that is, the lines are concurrent. Concurrent. So the question reads, the three vertices of a triangle are 2, 4, AB, minus A minus B. If the area of the triangle is 4 square units, find the expression relating A and B. Now let's look at it. We have a triangle formed like this. We have A, B. We have minus A, minus B. And we have 2, 4. Let's make it this way. So let's call this A, B, and C. We can find the area of this shape by dividing into sections. You can say triangle and trapezium, and then we add the area of the triangle to the trapezium and subtract the area of this triangle. We can also say the length of AB multiplied by the perpendicular height from C. So I use the latter technique. Let's find the length of AB. AB is equal to A minus A all squared plus B minus B all squared, square root of the whole. So which gives me 2 into root of A squared plus B squared. That's AB. Now let's find the equation for our AB. Equation for our line AB. So y minus b over x minus a will give me b minus b over a minus a. So 2b over 2a, b over a. So in short, the line passes through the origin. So ay minus ab is equal to bx minus ab. So ay plus ay minus bx equals 0. That's the equation of line AB. Now let's find the perpendicular distance from C. That's coordinate 2, 4. Coordinate 2, 4. 2, 4. So how do I get that? I just substitute into the normal form of the equation. So I have a into 4 minus 2 into b over square root of a squared plus b squared. That is the height. Now the area is half base times height. And let's see, what is base? 2. And what is the height? 4a minus 2b. And in the question we have been given that is equal to 4. So this plus this. So 4a minus 2b equals to 4. So 2a minus b is equal to 2. 2a minus b equals 2. So that is expression relating a and b.